Part 4, Section 5.3, the power-reducing formulas. These formulas allow us to express powers of trig functions with powers of no greater than 1. These formulas are extremely useful in calculus, and they come directly from the double angle formulas. If you look at these, especially the sine squared and the cosine squared, they come directly from these two double angle formulas. They're just simply solved for sine squared and cosine squared. And then for tangent squared, it's simply the sine divided by the cosine to get this. So these formulas come directly from here. If you know these, then you probably do not need to memorize these. Okay, so let's use the power-reducing formulas to rewrite each expression so that they do not contain trig functions of power greater than 1. Okay, so if I want to rewrite sine squared times cosine squared, what I'm going to do is I'm going to write it like this. That's sine squared times cosine squared. Okay, so now multiply here, and you get, this is the difference of squares on the top, so you have 1 minus cosine squared of 2x over 4. Okay, now cosine squared of 2x, they don't want you to have that because the power needs to be less than 1, so I need to do this formula again here. Okay, so I have 1 minus, I need to use this formula, and my angle is 2x. So this becomes 1 plus 2 times 2x. So this is cosine of 4x over 2 over 4. Okay? Now what I'm going to do here is I'm going to multiply top and bottom of this fraction by a 2. And I get 2 minus 1 plus cosine of 4x over 8. Now distribute the negative. 2 minus 1 minus cosine of 4x over 8, which simplifies to 1 minus cosine of 4x over 8. And that is the angle, that's the answer they are looking for. So you'll rewrite them and go to simplify them. If more powers show up, you keep going until they're all gone away. Okay? So let's simplify sine 8x times 1 minus 2 sine squared of 4x. Okay, so I have sine of 8x times, this is going to get ugly, so I'm using a bracket so I can have parentheses within parentheses and not get totally lost. 1 minus 2 times sine squared 4x. So I do 1 minus cosine of 2 times whatever this is. So this is 8x over 2. Okay. So I have sine of 8x times 1 minus, here these 2's cancel out. So I have that. So I have sine of 8x times 1 minus 1 plus cosine of 8x. So I have sine of 8x cosine of 8x. Okay? Now this is fairly simple, yes, but often will want you to recognize that you can generally go one step further. Notice that this is almost exactly this, okay? It is the double angle formula without the 2 in front. They will likely want you to recognize this and to write this as basically half of sine of 16x. Okay, because if you wrote this using the double angle formula, it would be 2 times sine 8x cosine 8x. That's why we divide it by 2, so that that 2 is taken care of when we make the conversion. Okay, now we also have half angle formulas. If an angle measures theta, then theta over 2 is half the measure of theta. So we have these formulas, and they're derived using the power reducing formulas, so they come from the ones we just did before. Now, unlike our other identities, the signs of our answers have to be manually determined based on the quadrant in which theta over 2 lies. So we didn't really have to worry about the signs in our others because the algebra just corrected them for us. But we have to be better than that for these half angle formulas because they involve taking square roots. And when we take the square root of both sides, we have to do the plus or minus. So we have to be smarter than our problems. We have to take care of that ourselves. So here are our basic half angle formulas. Sine of theta over 2 is either plus or minus the square root of 1 minus cosine of theta over 2. Okay? Cosine of theta over 2 is 1 plus cosine theta over 2. If you look at your power reducing formulas, you can see that what's underneath the radical is the same as what's here. You just had to take the square root of both sides. Okay? And then tangent of theta over 2, we have a version with plus or minus, but then we can also do the divisions and then our signs will be corrected and so on and so forth. So we have some options that don't involve the plus or minus here. Okay? So let's use these to find sine of pi over 8. Okay? So pi over 8, just as a quick sketch, this is pi over 4 here. So pi over 8 is going to be here. It is in quadrant 1. Sine is positive in quadrant 1, so just keep that in mind. Okay, so this is going to be positive. And what I have here is sine of pi over 8 is going to be equal to, it's going to be positive, 1 minus cosine of double this. Double pi over 8 is pi over 4 over 2. So I'm using this formula. I know it's positive because I know it's in quadrant 1. Double this angle is pi over 4. So I have the square root of 1 minus square root 2 over 2 all over 2. Okay. Now if I multiply top and bottom in here by a 2, multiplying this whole thing, you get the square root of 2 minus the square root of 2 over 4. And this is the square root of 2 minus the square root of 2 over 2. You will have nested square roots a lot. Okay? All right, so let's find cosine of negative 3 pi over 8. Well, cosine of a negative, cosine is an even function, so this is the same thing as cosine of positive 3 pi over 8. And if I double this, I get 3 pi over 4. Okay, well, let's figure out what quadrant we're in, okay? 3 pi over 8, 3 over 8 is less than 1/2. So that's going to be in quadrant 1. So it's going to be positive as well. 3 pi over 4 is over here, but half of it is in quadrant 1. Okay? So I'm going to use the positive version right here. And I have the square root of 1 plus cosine of 3 pi over 4 divided by 2. Cosine of 3 pi over 4 is negative square root 2 over 2. Over 2. And if you notice, we have exactly the same thing as up here. It's just this was started off as a minus sign and this was a positive cosine. Here we started off with a plus and we got a negative, but we have the same values. So the arithmetic is going to work exactly the same. And you have the square root of 2 minus the square root of 2. So nested square roots over 2.